Okay, so quickly moving on now to look at horizontal asymptotes. So what I'd like you to do, get started, is to find the vertical asymptotes for these three functions. And don't bother with, actually just do these two. Don't bother with this one because of Labor Day, I've moved absolute numbers from this week to next week, so don't worry about 3. Okay, so this term in term 2, we're looking at vertical and horizontal asymptotes. So this is where the degree of x is high in the denominator or equal in the denominator to the numerator. So before we get 1 over x, that means that the degree of x in the denominator was 1, the degree of x in the numerator was 0, therefore it's up here. If we start making the degrees higher in the numerator, we get what we call oblique asymptotes, which look kind of like this. And that's term 3 stuff. Okay, so we'll be touching on this again next term in a bit more complexity. This is what we're looking at here, where a horizontal asymptote can actually be something other than 0. Okay, so these are the vertical asymptote here, and this lesson we're looking at the horizontal asymptote. Okay, so if we want to find the horizontal asymptote, what we need to do is, there's no real shortcut like there is for the vertical asymptote, or there is actually, we'll teach you in a second. But first thing you need to do is make x approach infinity. So 100, and we want to see what happens to y. So as x approaches infinity, y is approaching 0. So in this case, the horizontal asymptote is y equals 0. Relatively easy. However, if the degrees are the same between each, so here the degree of x is 2, the degree of x here is 2, they are the same, therefore we can have a horizontal asymptote that is not 0. In this case, we need to look at the highest degree, in this case x squared, degree 2 is the highest degree. This is x2, x0, so the 2 is the bigger one. We just need to look at the coefficient and have the coefficient of the numerator over the coefficient of the denominator. So in this case, it's 3 divided by 2. 3 over 2 is 1.5. So here we have our horizontal asymptote. As x approaches infinity, y approaches 1.5. But y will never, ever, ever actually hit 1.5. Okay? So we can go on to a million, quadrillion, whatever. Y will never be 1.5. Your calculator may say so because your calculator is going to have to round at some point, but in reality it never will. So we look at the highest degree because as x increases, you might have an x here and an x here. So yes, as x increases, you're going to increase these as well. But the higher the degree, the faster it will increase. Okay, so really, if everything else is equal, we just look at the highest degree. As soon as we start making these unequal, then we start getting these oblique asymptotes, which we're not looking at this term. Okay, so as x approaches infinity, x squared approaches infinity faster. So the bigger the degree, the more impact it's going to have. Okay, so our vertical asymptotes are where the function approaches y, where the function approaches as y approaches infinity, so that we're looking at an x, and horizontal asymptote is where the function approaches as x approaches infinity. To find the vertical asymptote, you just take the denominator, look at what x would have to be for the denominator to be 0, and for the horizontal asymptote, you just make a fraction of the coefficients. Okay, so we have 3 functions here. And I want you to find the horizontal and the vertical asymptotes of all three. Now notice here, now I'm writing function of x instead of y. fx does mean y, but this is just an easier way of writing it for future reference. Okay, so if you're used to saying y equals this, it means the same thing. I want you to write a paragraph saying why some functions are unable to define certain values, and have a read of this. Read the following text, provide a description of real numbers. What is a real number? Okay, so just have a quick read of that. Write a sentence 10 words or less. And what we might do is, because we still have Desmos doing its thing from the last lesson, I might just, let's go away. So y equals ax squared over over bx squared. And if we make this okay, we'll just pause this. There we go. So that should work. That should make it nice and good. So what we are seeing here is we are changing the horizontal asymptote here as A and B change. So the horizontal asymptote is always going to be A divided by B. So in this case, it's negative 2.74 divided by negative 1.6, which negative 2.74 divided by negative 1.6 equals 1.7125. Yeah, that looks about right. Okay, so we're just looking at A divided by B. So you can just have a bit of a gander at this. And just stop at random places. So 1.43 divided by negative 6.67, so that's going to be around about negative 6-ish, something small like that, and you can see that is kind of what we get. And if we, here we go, so B is now negative 2.09, so we can expect it to be, let's make A1 be negative 2. So what's 1 divided by negative 2? It's going to be negative a half, and we can see that's kind of where we're going. If we make B negative 5, it'll be 1 divided by negative 5, which is negative 0.2. There we go. And if we make B 5, it'll be 1 over 5, so 1/5. But make this 5, let's make it 10. 10 divided by 5 is 2. 10 divided by 1 is 10. 10 divided by 10 is 1. 10 divided by negative 7 is 10 over negative 7. That's, I'm not sure how. It'd be negative 0.7, of course. And it's going to be just there. Divided by, so that'd be negative 0. That'd be 10 divided by 3, that would be 3.333. Boom, done. So yeah, have a look around with this as well.